So in the last class, we were speaking about how we can use in SPARQL certain features to be able to query over multiple graphs, not just one graph. And this is enabled through the concept of a data set where we have one default graph, which has no name, and a bunch, as many as we would like, a bunch of named graphs, which are pairs of IRIs, the names of the graphs, and the graph themselves. And we can use from and from named to construct a data set. So we can use from to define the default graph, which will be the RDF merge, essentially the union keeping blank nodes distinct of all the graphs that we mentioned in from, along with the name graphs that we mentioned in from named. So from we use to define the default graph of the data set we're going to use for querying, and from named we use to select some of the named graphs that appear in the data set. So afterwards, we have a third feature, which is graph, which we can use in the query in order to select parts of the data set. So graph is used effectively to query over the named graphs that we've constructed in the data set for the query. So it allows us to specify for example, the IRI of a specific named graph over which we want to run some part of the query. Or we can specify a variable such that the variable will match the names of all named graphs, and then the query will be evaluated over those. One by one, in fact. So it does not access the default graph. So if we have data in our default graph and we use the graph feature, the default graph won't be used for the part that's inside the graph. However, if we don't specify graph, by default, we will access the default graph. So we'll see some examples of this to illustrate all of the different combinations of things that we have. So here we have a query like we've seen at the start of the class. We have select distinct S where SPO. So asking for all of the distinct subjects in the data, and here's our data set where we have a default graph here, which has no name. Okay, this is not a name, this is just indicating this is the default graph with no name. We have a graph for Sharknado called Sharknado.ttl and a graph for Sharknado 2 called Sharknado2.ttl. So the default graph we use to just essentially list all of the movies of the series, and then every movie has associated with it a different graph, named graph. Okay, so again, a named graph is a pair of a name and an RDF graph like this. So we can have as many as we like, as many named graphs as we want, but we can only have one default graph. So here's our query asking for all of the distinct subjects, and let's assume that this is so this is the data set that we have indexed in our SPARQL engine. The question is, what solutions would this query return? And the answer is that we would expect all of the distinct subjects in the default graph. So by default, we access the data in the default graph only. So the solutions in this case would be Sharknado series. Right? So since we haven't specified any graph clause here, we'll get the solutions for this. The only solution we'll get will be Sharknado series. So when we don't specify any graph or anything in the query, by default, we're accessing the default graph. No graph clause, so answers come from default graph only. Okay, in this case, we're going to use from to construct a new default graph that we're going to use in our query, right? So what we're saying is that for this query, we would like to take the default graph that is the merge of Sharknado and Sharknado2.ttl. Since they have no blank nodes, it's essentially just we take the union of both of these graphs, of all the triples in these two graphs. So what solutions would this query return? Well, now our default graph is composed of the union of these two graphs. So we would expect to return Sharknado and Sharknado2, right? So when we use this from feature, we delete essentially the data in the default graph, and we replace it with the union of these two graphs here. So since we have no graph, we're going to access the default graph, and that would be giving us Sharknado and Sharknado2, right? So there's no graph clause, so the answers come from the default graph, which we've now redefined using from. we've defined a new default graph just for this query using from. Okay, what about from named? So if we use from named, what we're going to do is create a new data set again, where we have an empty default graph because we have no from, and we just have one named graph, which is this one here. So in this case, we import this graph into our query, but rather than import it into a default graph, we're going to store it or keep it as a named graph in the data set. So what solutions would this return? This would return empty solutions. Empty solutions because our default graph here will be empty. We haven't used from to define a new default graph. So there's no graph clause, so the answers come from the default graph, which is empty, right? So when we use from or from named, we automatically clear the default graph and we kind of start a new data set from scratch for the query. Any questions or doubts so far for these three examples? Okay. If not, how do we query named graphs then? How do we access named graphs in our query? Well, in this case, we have no from or from named. So it means that by default, we're using the index data set, whatever we stored in our engine, right? So we don't change the data set. What we say here is we use the graph name feature of SPARQL. So essentially we say, we want to run this part of the query only over the sharknado.ttl graph. So this basically says, okay, we want the distinct subjects of the sharknado.ttl graph, which will be Sharknado, right? So we can use graph to access specific named graphs or access all of the named graphs. To access all of the named graphs, instead of putting a name, we can put a variable like G. So we say from sharknado.ttl, and then we say graph G, okay, SPL. In this case, what we're looking for are the unique subjects of all named graphs. Any idea what this would return, this query? So we'll return all of the distinct subjects of all of the named graphs, right? But in our data set that we've defined for our query, we've used from, which is sort of reinitializing the data set. So we've defined a default graph, but we haven't defined any named graph. We haven't used from named at all. So we'll have no named graphs. So essentially this means that this query will return empty solutions again. And this is because we have no named graph specified, and graph does not access the default graph, right? So, okay, if we had from named Sharknado, then in our query data set, we would have this named graph in it. So when we run graph G, what this will give us will be the solution with S, the subject of this named graph, and the graph itself, sharknado.ttl. Okay, so this only accesses whatever active named graphs we have in the query. It will not access the default graph. So in this case, the graph accesses the one and only named graph, which is sharknado.ttl. Now we can combine from and from named. In this case, we use from to define the default graph as this graph here. And we import as well a named graph, which is this graph here. So what we have now this time is a slightly more complex query where we have a join. So we have a join between a named graph here, or each named graph, and the default graph. Okay. So what we're looking for will be this, in this case, will match the named graph, which will be sharknado.ttl. So we'll have sharknado.ttl, and here we'll have every triple. This will match every triple in the sharknado.ttl graph. I'm sorry. Yeah, no, that's correct. Yeah, so from name says sharknado.ttl. And then we use, we have a join where we say XQO. So we're looking for all of the triples in the default graph whose object appears also as an object in the name graph. Okay, so we have this join on O. So if we look at this, we see that the only, no, in fact, there's not. No, I'm mistaken. I'm mistaken. This is the name graph. This is the default graph. So we're looking for objects in this graph here that appear as objects as well in the default graph here. So in this case, this would be in0ing appears as an object in both. So in0ing will match O here. So what we will get, we're asking for X and Q. So we'll get in0ing and Sharknado 2. So what this illustrates is that we can take one part of the query from a particular name graph or over each name graph, and we can also run parts of the queries over or default graph and join them or combine them using any of the operators we have seen before. So this is it's X and Q. I'm sorry. So we're returning the subject and the predicate. So Sharknado 2 and stars. So X and Q. O is in in0ing, and this is because it matches a triple in the name graph. In0ing star Sharknado. So we have this join on in0ing for O. Okay, so that's all the examples. This is kind of maybe a slightly trickier feature. I think that causes some confusion. So hopefully with the examples, it's more clear. Any questions or doubts? Okay, so if not, we can start to look at Lab 7. So in Lab 7, we're going to give you some data, and you're going to use the RDF Explorer system to run some SPARQL queries. It's worth mentioning that in the case of SPARQL, we're really running queries over data. So not ontologies, or we're not really doing inference or entailment or anything. So it's much more similar to databases. There are proposals for how to extend SPARQL with entailments so that you get the answers also under a certain entailment regime. Those have not been really adopted so much because of kind of, you know, it's expensive to provide SPARQL queries answers under entailment. So it's worth keeping in mind that. Of course, we could simply materialize all of the data like we've seen in the labs and then index that graph along with the input data, right? So we could just run a reasoner and materialize a bunch of data and then index that as if it were input RDF data. But in this case, we're not doing that. So we're focused just on querying the data directly. Yep, okay. If there's no questions or doubts, comments. Okay, in that